Part 3.6 Limitations of Ohm's Law. Although Ohm's Law has been found valid over a large class of materials, there do exist materials and devices used in electric circuits where the proportionality of V and I does not hold. The deviations broadly are one or more of the following types. V ceases to be proportional to I. The relation between V and I depends on the sign of V. In other words, if I is the current for a certain V, then reversing direction of V keeping its magnitude fixed does not produce a current of the same magnitude as I in the opposite direction. This happens, for example, in a diode, which we will study in chapter 14. Here's a graph. Please take note to the graphs. The relation between V and I is not unique, that is, there is more than one value of V for the same current I. A material exhibiting such behavior is GAAS. GAAS. Materials and devices not obeying Ohm's law in the form of equation 3.3 are actually widely used in electronic circuits. In these few subsequent chapters, however, we will study the electrical currents in materials that obey Ohm's law. Next, part 3.7 Resistivity of various materials. The resistivities of various common materials are listed in table 3.1. Table is at back side. I will show you. The materials are classified as conductors, semiconductors, and insulators, depending on their resistivities in an increasing order of their values. Metals have raw resistivities in the range of 10 to the power -8 ohm meter to 10 to the power -6 ohm meter. At the other end are insulators like ceramic, rubber, and plastics having resistivities 10 to the power 18 times greater than metals or more. In between the two are the semiconductors. These, however, have resistivities characteristically decreasing with a rise in temperature. The resistivities of semiconductors are also affected by the presence of small amount of impurities. This last feature is exploited in use of semiconductors for electronic devices. This is table 3.1 Resistivities of some materials. You should take a note here by yourself. Take a note through this chapter, through this table yourself. Let's move further. Commercially produced resistors for domestic use or in laboratories are of two major types: wire bound resistors and carbon resistors. Wire bound resistors are made by winding the wires of an alloy with manganese, constant, nichrome, or similar ones. The choice of these materials is dictated mostly by the fact that their resistivities are relatively insensitive to temperature. These resistances are typically in the range of a fraction of an ohm to a few hundred ohms. Resistors in the higher range are made mostly from carbon. Carbon resistors are compact, inexpensive, and thus find extensive use in electronic circuits. Carbon resistors are small in size and hence their values are given using a color code. Resistor color codes. Take a note through this table yourself. If you want me to read these tables, please comment below. I will read these tables from the very next video. If you want me to do that, please comment below. The resistors have a set of coaxial colored rings on them whose significance are listed in table 3.2. The first two bands from the end indicate the first two significant figures of the resistance in ohms. The third band indicates the decimal multiplier as listed in table 3.2. The last stands for tolerance or possible variation in percentage about the indicated values. Sometimes this last band is absent and that indicates a tolerance of 20%. For example, if the four colors are orange, blue, yellow, and gold, The resistance values is 36 into 10 to the power 4 ohm with a tolerance value of 5%. Here is a figure. Please take a note. Okay. That's it. Next part will be in the next video. Thank you.